To understand how to split the atom, you need an incredible grasp of theoretical physics. But to understand how the woman who provided the definitive breakthrough for that discovery was erased from history, you have to look at who controlled the narrative. For 3 decades, Lise Meitner and Otto Hahn operated as a single, highly effective scientific unit. She was the brilliant theoretical physicist. He was the masterful experimental chemist. Working together here at the Kaiser Wilhelm Institute in Berlin during the 1930s, the pair set their sights on a massive challenge. They began firing newly discovered particles called neutrons at uranium, trying to see what kind of heavy radioactive elements they could create. Their success relied entirely on an inseparable feedback loop. Hahn used chemistry to observe the physical results of their experiments, and Meitner used physics to explain exactly what those observations meant. Neither discipline could succeed in a vacuum. But the political reality in Berlin was rapidly deteriorating. As the Nazi regime seized power, they systematically purged universities and laboratories, destabilizing the entire academic community. Because of her Jewish heritage, Meitner was stripped of her professorship. By the summer of 1938, her colleagues had to smuggle her out of the country, forcing her into a sudden, harsh exile to Sweden, with little more than the clothes on her back. Sitting in a small institute in Stockholm, Meitner was isolated. She had no laboratory, no equipment, and most devastatingly, she was cut off from the research partner she had worked beside for over 30 years. This geopolitical fracture eerily mirrored the very physics they were studying. A highly stable, unified core had been violently struck by an outside force, splitting it apart and altering the trajectory of modern science. Hahn remained in Berlin, where he and his assistant Fritz Strassmann continued the neutron bombardment experiments alone in the laboratory. By December, they found something that made absolutely no sense. When they bombarded heavy uranium, the chemical residue left behind included barium, an element that is roughly 40% lighter than uranium. As a chemist, Hahn was baffled. The prevailing wisdom held that you could only chip tiny fragments off an atom. There was no known chemical mechanism to explain how a heavy atom could instantly transform into a much lighter one. Desperate for an answer, Hahn wrote a letter to Meitner in Sweden, outlining his bizarre barium results and begging her to find a physical explanation for his chemical anomaly. Hahn had hit the hard limit of his discipline. His chemistry could identify exactly what was sitting in his Petri dish, but it was entirely blind to how it actually got there. Over Christmas in 1938, Meitner took a walk through a snowy Swedish forest with her nephew, Otto Frisch, who was also a physicist. As they walked, they dissected Hahn's letter. Meitner realized the answer lay in the liquid drop model, picturing the heavy uranium nucleus as an unstable drop of fluid. When the neutron strikes, the impact forces the entire drop to oscillate, elongating and pinching in the middle before cleanly splitting in two. But when Meitner calculated the masses of these 2 new fragments, she noticed a discrepancy. The 2 halves combined weighed slightly less than the original uranium atom. A tiny fraction of mass was missing. Drawing on Einstein's famous equation, E equals mc squared, Meitner deduced that the missing mass hadn't vanished. It had converted into a massive release of pure energy, about 200 million electron volts per atom. In that moment, Meitner and Frisch had theoretically defined nuclear fission, the physical interpretation that turned Hahn's barium anomaly from a confusing error into a scientific revolution. In January 1939, Hahn and Strassmann published their chemical findings in Germany. Fearing repercussions from Nazi authorities, Hahn made the choice to deliberately omit Meitner's name from the paper. Meitner and Frisch published their physical explanation of the process in the British scientific journal Nature just a month later. The ultimate institutional betrayal arrived in 1944. The Nobel Prize in Chemistry for the discovery of nuclear fission was awarded solely to Otto Hahn. Her erasure was the result of overlapping institutional barriers. Her physical absence and exile made her easy to overlook. Committee members like Manny Siegbahn held deep-seated biases against women in science, and the Nobel institution itself struggled to recognize a breakthrough that belonged to both chemistry and physics. The Nobel Committee focused on the visible chemical identification, ignoring the physical theory that actually explained what had happened in the lab. Even after the war, Hahn perpetuated a myth that chemistry alone had discovered fission. Driven by pride and self-preservation, he continued to write Meitner out of his narrative. While Hahn defended his sole claim to the discovery, Meitner took a much different stance. When the horrific potential of their work became clear, she outright refused to join the Manhattan Project or work on an atomic bomb, prioritizing humanity over notoriety. A physical metal is an artifact of the politics of its time, but scientific truth outlasts the committees that hand them out. Hahn had the barium, but without Meitner's physics, his observation was merely noise in a petri dish. Lise Meitner provided the physical insight that allowed the atom to be split. She demonstrated that a discovery is only completed once its meaning is understood. Her legacy is the theory itself, the foundation of everything we know about the nuclear world.